Okay, and welcome to Math 8, Unit 4B, Lesson 2. Today's objective is you'll use the, scholars will find the, volume of cones and use the volume formula to find missing dimensions of cones. So we were talking about cylinders, now we're talking about cones. So let's talk first about how we find the volume of a cone versus a cylinder. So the formulas for cones and cylinders are very similar. So here's the formula for the cylinder was pi times your radius squared times your height. The volume for a cone is 1/3 of pi times your radius squared times your height. So you can sort of imagine that a cone's inside this cylinder, and we could actually fit like 3 of them. So if you had a cone and a cylinder the same radius and height, you could fill the cone 3 times with water to fill the cylinder. Okay, so it is 1/3 of the volume of the cylinder, the same size. So let's practice. Again, our volume is 1/3 of pi times our radius squared times our height. So here we have a diameter of 4. That means our radius is going to be 4/2, which is 2. We have a height of 6. So our volume is 1/3 of 2 squared times 6 times pi. So our volume is 1/3 of 4 times 6 times pi. Well, 4 times 6 is 24. So our volume is 1/3 of 24 times pi. So 1/3 of 24 is simply going to be 8. Our volume is 8 pi. And again, if we wanted to get a approximation, it would be approximately 25.13. And this is meters cubed, because that's our unit is meters. Okay, so let's try another one. Here, now for once they've given us our radius, and we have our height. So again, our volume is 1/3 times our radius squared times our height. So, times pi. That should be a pi there. There we go. That sort of looks like pi. So, our volume is 1/3 times 2 times pi. Our volume is 2/3 of pi. Again, this is in feet cubed. Again, if we wanted to do this more exactly, we can put it in our calculator, get 2/3 times pi, gives us approximately 2.09. Volume is approximately 2.09 cubic feet. Okay, let's try another one. This one, they've given us our volume. They've given us our radius. We are missing our height. So I have 956 equals 1/3 of 9 squared times h times pi. So I have 956 equals 1/3 times 81 times h times pi. 1/3 of 81 is going to be 27. So I have 956 equals 27 times h times pi. And I'm going to divide both sides by 27 pi. When I do that, I get my volume for h. So I've got 956 divided by 27 times 3.14 gives me a volume of approximately 11.2. It's 276, which becomes 28 feet is my height. Okay. So, finding our height again. I have a radius of 15. I have a volume of 7,200. So I have 7,200 equals 1 third of 15 squared times h times pi. So I get 7,200 equals 1/3 of 225 times h times pi. 1/3 of 225 gives me 75. 7,200 equals 75 times h times pi. Again, I'm going to divide both sides by 75 pi. Make sure when you put this in that you make sure it's dividing by pi. So 7200 divided by 75 pi gives me a height of 30.557, so that's 0.56 yards is my height. Okay, now let's talk about how we can use this in the real world. So what is the volume of sand in the hourglass? You can see that it is a cone. At the top here, I'm just looking for the volume of the hourglass, so I'm only needing this information here. So I'm going to do my volume equals 1/3 of 10 squared times 24 times pi. So my volume equals 1/3 times 100 times 24 times pi. So it's 1/3 of 2,400 times pi. So it's 800 times pi. And yet if I wanted more exact, I can just do 800 times 3.14, which gives me a volume of 2,512 millimeters cubed. Okay, one more real world example. Okay, the inside of each glass is shaped like a cone. You can see them. See these cones here. See how they come down. Okay, which glass can hold more liquid? First of all, to find out which glass holds more liquid, we find out which one has the greater volume. So we're looking for greater volume. That's what can hold more liquid. So we're looking for the greater volume. So let's start with this one with glass A. So this one has a radius of 4. So our volume for glass A, volume equals 1/3 times 4 squared times 8 times pi. So the volume is 1/3 times 16 times 8 times pi. 16 times 8 is 128. So our volume is 1/3 of 128 times pi. So 128 divided by 3 is 42.67. So in this case, our volume is 42.67 pi. And I'm going to leave it like that. Now let's come over to glass B. We're going to do glass B in red. So glass B, our volume equals 1/3 of 3 squared times 10 times pi. So it equals 1/3 of 3 squared is 9 times 10 is 90 times pi. So this is our volume. 1/3 of 90 is 30 times pi. So we can see that glass A has a larger volume. It's 42.67 times pi, whereas glass B had a volume of 30 pi. So glass A has the larger volume. Even though it's shorter, it's got the larger volume because it's got a little bit wider cone. Okay, so go ahead and try your problems in class and ask any questions you have. I'll see you then.